Hello, and welcome to Mirrorverse Education. Today we are expanding expressions using area models. Use the distributive property to expand the following expression, -5/10 times the quantity of 2x plus 6. This question is really asking us to rewrite the product of -5/10 and the quantity of 2x plus 6 without using grouping. That means we shouldn't really have any parentheses grouping terms together when we're all done. We're going to be thinking about this problem by visualizing a rectangle. When we look at the expression -5/10 times the quantity of 2x plus 6, we have a product, two terms. Just like the area of a rectangle is length times width, two terms multiplied together. We can think of -5/10 as the length and 2x plus 6 as the width. Let's label our rectangle. So because 2x plus 6 is also a sum, let's split the rectangle into two parts. On the left, to find the area, length times width would be -5/10 times 2x. And on the right, length times width would be -5/10 times 6. As we simplify, we find that the left area, -5/10 or -1/2 times 2x, leaves us with -x. And on the right, we see that if we multiply -5/10 times 6, we end up with -3. Because those are two parts of a rectangle, they're two parts of our total area, so we're going to add them together. And we end up with -x plus -3. Or, because adding a negative is exactly the same as subtracting a positive, we can rewrite it maybe a little cleaner as -x minus 3. So what we find is that -x minus 3 is equivalent to -5/10 times the quantity of 2x plus 6. Okay, let's take a look at another problem. This time the coefficient is going to be a fraction. It says use the distributive property to expand the following expression, 3/4 times the quantity of 3x minus 1. Again, essentially we're saying how can you rewrite the product of 3/4 and 3x minus 1 without grouping? So we'll pick our length and width again. 3/4 will be our length, and 3x minus 1 will be our width. Okay. So when we split this rectangle into two parts, I always feel like subtraction doesn't make a ton of sense in the width. So instead, I like to rewrite it as adding a negative. And that way we see that we have one part of the width is 3x, one part of the width is -1. We add them together to get the total width. So the area, length times width, of the left part of that rectangle is going to be 3/4 times 3x. And on the right, 3/4 times -1. And we simplify, we end up with 9/4 x, and then on the right, -3/4. Again, we add those back together to get the total area. And just to make things a little neater, I do know that 9/4 is equivalent to 2 1/4. We don't normally like to leave fractions as improper fractions. We can rewrite it as a mixed number. So when we write our final answer, we have 2 1/4 x plus -3/4. And again, do you see where we're adding a negative here? We can definitely rewrite that as subtracting a positive. So we do have a second option of writing our final expression as 2 1/4 x minus 3/4. Okay, so thanks for using area models with me today to expand some expressions. I find it a really useful visual tool. If you're looking for more help, we'd love for you to come check out mirrorverseeducation.com and feel free to subscribe to our channel. Thanks so much.